All right. Good morning, everybody. Welcome to the first day of Identiverse 2019 here in Washington, D.C. And you have decided to spend your Tuesday morning learning about a security protocol. So these are the hardcore nerds. These are my people. Welcome. Yeah. All right. My name is Justin Richer. I'm an independent consultant based out of Boston. And we are here today to talk about a protocol called OAuth 2.0. Now, I want to warn you guys and sort of prepare you a little bit. This is the 3-hour version of a 2 to 3 day course that I usually give at a lot of different companies. So we are going to be going a little bit quick, but we are going to be going in some pretty reasonable depth today. I will be happy to take questions and comments as we go through. Keep in mind, because there is a lot of material, I may defer answering your questions until we get to the appropriate part of the presentation, because it's probably in there somewhere. I've been doing this course for a while now. You could also try the home edition of this course. A lot of the material here is also available in a book that I wrote along with Antonio Sanso, a brilliant researcher from Adobe. This is available from Manning Press. It's also available in Korean and in Japanese now, which is kind of mind-blowing. And if you want to grab me after today's talk, I have a discount code for the English edition. Sorry, I don't have discount codes for the Korean and Japanese editions. And the Chinese version's not published yet, but they're working on it. But see me after the talk. I can get you, weirdly, 39% off the English version if you buy it through the original publisher. All right? So we're going to start this off, as all good things, as all good classes anyway, with a question. What is OAuth 2? All right? Who here knows? Yes, sir. Okay, so it was a Federation standard used for the assertion of identity and a minor amount of permissions. Great, hold that thought. Anybody else? Yes, sir. Mostly used for authorization. And also, I think, basically the protocol is to get a token and not put passwords again. Okay, so get a token and not use passwords and again. So anybody else? Yes. A delegation protocol. Have you taken my class before, sir? Okay. You'll see why in a moment. Anybody else? All right, last one. This is not OpenID Connect, sir. Hold that thought. We'll get to that later. Thank you, sir. All right, so this is what OAuth 2 is according to the specification, but this is the important part. Fundamentally, it is about allowing third-party applications to get limited access to some sort of HTTP service or API on behalf of a resource owner. So OAuth gets called an authorization protocol a lot of the times, but as we just heard, it is, in fact, at its core, a delegation protocol. You're delegating your authorization to use something to a piece of software, but ultimately, what OAuth allows, the mechanics that OAuth allows, are all about delegating that right of access. That's what all of the mechanics and bits and parts of OAuth are doing here. So these are the players that are involved. And we'll get to know them a lot over the coming morning, all right? So first off, we have the resource owner. May also hear this called the end user. This is usually a person. They usually have access to a web browser. Importantly, though, they have access to some resource API, which might be their own data. It might be data about them. It might be data that's not related to them as a person at all, but just data that they have access to. Right? So the name resource owner can be a little bit misleading because the data doesn't necessarily have to be about this person. The important thing, and the thing that makes this whole delegation protocol work is that they have the right to delegate access to that API to a piece of software to act on their behalf. Now that API in the OAuth world we call the protected resource, also sometimes known as the resource server. And this is some type of web-based API. OAuth is a web-based protocol with security controls that not only protects things, but allows access to things as have been delegated by the resource owner. And as is usually the case, folks, there are plenty of seats open right in the front row. Now, here's kind of a tricky one. And also, I'm going to ask, the room is a little bit full, so if people wouldn't mind maybe scooching from the edges a little bit. We've got a couple of stragglers. Let's get everybody in. So the client application, this is where things start to get a little extra confusing for people, because if you've been working in web programming for a while, you're probably going to think, oh, that's the browser. You know, that's the HTTP client that's going and calling the HTTP server, right? Not actually the case. The client is the piece of software that is going to be calling that protected resource API. That's it. It might be running in a browser. It might be a native application. It might be a web service. OAuth really doesn't ultimately care. It's whatever piece of software is calling that API. That's what we're going to call the client. Right? This is ultimately what we're trying to solve. We're trying to get the resource owner to give a set of rights to the client software so that it can access the protected resource. Right? We're trying to close that loop right there of rights, because the resource owner has access, and we want to give the client access. This is a problem that we've had for a very, 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 very long time here, right? We've been solving this in lots of different ways. And OAuth hasn't been around forever. It's starting to feel like that to me. More on that later. But how did we solve this without OAuth and without a delegation protocol? Well, one of the things that you do in a lot of enterprise environments, if somebody logs into your application, you're going to use whatever they use to log into your application to log into the API. Right? So they're going to show up and they're going to give you their username and password, and you're just going to turn around and replay that. You see this especially in enterprise spaces where you've got a single account that accesses a whole bunch of different things. You also see it within some sort of large providers. This used to be the most common way that people would do this type of connection. And interestingly, who here has ever deployed LDAP-based authentication? That's what it is. LDAP is give me your password and I will go use your password to see if it's real, right? LDAP is a benevolent man-in-the-middle attack. So what are some problems with this? So first off, I'm going to pick on a couple of people in the audience here. So you, sir. Let's say that you have a protected resource that people want to use, right? So I'm a user, and you've got an API, and you've given me access to that API, and you've allowed me to delegate it to that. And how do you pronounce your name, sir? Jit. Thank you. So I need to get to Jit's API, all right? So now somebody is going to write a client. So Carol, you're going to write a piece of client software that I want your software to be able to access Jit's API. Let's take a look at what happens in this pattern. So I show up at Carol's service, and I log in. She turns around, takes my username and password, hands it over to Jit's API. So, Jit, who just showed up at your API? No. As far as you're concerned, it's me, because she has my username and password. You have no idea that Carol exists. Right? So this is impersonation. The only way that Jit's API knows who's there is by this primary credential. So there's no way for me to be able to say, I want Carol's API only to have read access, or to get data but not the sensitive metadata about things. You know, there's also no good way for me to turn off access, because as soon as I walk away from Carol's application, guess what? She still has my password. She can go keep using that all day and night, and there's nothing I can do about it. Well, maybe I could change my password, But remember, we're in kind of an enterprisey single sign-on kind of thing anyway. So I changed my password, and the next time I show up at Carol's application, guess what? She gets my new password, and she gets access again. And maybe I showed up at Sala, thank you, at Sala's application, and Sala decided to use Carol's system, which calls JIT's API. And guess what? Now Carol is in the loop, and I had no idea and ultimately no say in it. This is what you could call a bit of a problem. But we built a lot of systems that work like this. I've seen domain cookies get replayed between web portals and APIs all the time in the enterprise space. Now, let's take a little bit. So we can agree that this while functional has a bit of problems. One of the other big problems with this, though, what happens if JIT's API is Google and Carol's software is Facebook? So when I log in to Facebook, my Facebook password isn't going to work with Google because we're all good and we don't reuse passwords across sites, right, folks? Says the co-author of the NIST password guidelines, right? Wow, that got sleepy in here. All right, I'll try to keep you all awake. So here's the thing. What is Carol to do in that case? She still wants to be able to access stuff over at JIT's API. If she can't steal my keys, well, she can just ask for them. How many times have you gone to a website and said, like, hey, give me your email address and your email password, and I promise I will do nice things and I won't do bad things here, right? We see this all over the place. Did you have a comment, sir?
It's funny you bring up Facebook because they did the exact same thing with that.
Yeah, Facebook does it. LinkedIn is probably one of the worst offenders of this, trying to get people's contacts databases in order to build out your professional network. But we see this all over the place. We have the same type of impersonation problems. At least I can change my Google password and cut Carol off now. But that's still a really big pain. It also doesn't work if what I'm logging in with, like multi-factor authentication and all this other stuff, can't be replayed. And we're building systems that you can't replay with our identity systems now. Also, the biggest problem that I have with this as a security professional is that this is training users to give away their shareable credentials if somebody asks nicely, right? That is not what we want to be teaching people to do. Because all it takes is one attacker to ask nicely enough and people be like, oh yeah, so this is just like the time that I went and downloaded my books, or my address books and all of that other stuff. So this is also problematic. So what if instead we go back to, we'll back it down to our more sort of, simpler enterprise case a little bit. What if instead of even seeing my password, JIT gives Carol a password that lets Carol do whatever she wants on the API on behalf of whomever. Sounds a little crazy when I say it like that, but this type of universal key that's good for opening the door no matter who's knocking, we call that an API key. We do this all the time too. Because if you think about it, you have an API key, you're just allowed to call the API and whatever's there. It's not on behalf of a single user. Good news is that we now know that it's Carol that's there, but we've lost the information about that it was me that said that this was okay. So JIT can no longer, in any trustworthy way, serve information that is only about me unless you absolutely explicitly trust Carol's API. Trust Carol's software to call your API. And now, Carol, you now have to specify that it was me that showed up at the door, and we have to trust you not to lie about it. And if you're working in a security space, that you shouldn't trust software not to lie to you, right? You should make it impossible for the software to lie. So we've got a couple of systems now that address parts of this. We don't want my regular password chucking around. We want to know that Carol is involved and that I'm involved. So let's combine things. Let's give me a password that is only good for my use of Carol's software to call JIT's API. So there's some great benefits to this. So when this password shows up, JIT, who is making that call now? You do have the notion that it's from me because this is going to be you to me, but you know that it's also not just me, because this is something that I specifically said, this goes through Carol's software. And we can now say that, hey, I only want Carol to have read access. And you're like, okay, fine. You know, when I show up with my regular password and log into your website or whatever, you're like, yeah, you can do whatever you want. It's your stuff. But when Carol shows up and tries to you know, upload or delete or whatever, you're like, no, you can't do that. So this has some really great security properties. So what's the downside? The usability of this is abysmal. I now have to go over to JIT's system, generate a brand new password, copy that over into Carol's application when she asks me for that password, and I put it into her software so that she calls it. One of the biggest uses of this, and by this I'm dating myself a little bit, was Google Code's Subversion repositories. So I see some knowing head nods. You know where this is going. So Google Code had the ability to set an application-specific password so that your Subversion server would be able to call, or sorry, your Subversion client would be able to call the SVN server, and it would have exactly this property. You would have a password that was specific to the user, that was specific to that particular client. This was all good. However, what happens in the real world? You load up your Subversion client, and it says, hi, log into Google. People be like, okay, I know how to do that. I'm going to type in my Google address and my password, and it's not going to work. And it's going to keep failing. And it's going to continue automatically trying it every time that I try to do a Subversion refresh or anything like that. It's going to keep replaying my password again and again and again and again. And an interesting side effect of this type of setup is that the failure mode of some Subversion clients is that they just keep trying really hard with that password that's not working. I know this because I took down an LDAP server once with this exact pattern. Not intentionally that time. So we're getting close. We're getting close to something that works. So let's try to keep our security properties, but make the usability better. Security and usability are often fighting with each other. Although I will say as an aside here, when they do fight with each other, usability always wins. Absolutely every time. And so what we need to do is make the usability for people better, make the usability for developers better. Because remember, on Google Code, like that wasn't normal people that was using it. That was software engineers, right? Software engineers, by the way, we are not normal people. And we should know better. You know, these are people who should have been able to go through this complicated UX and failed quite a lot. So let's introduce another player into the mix that is going to allow us to manage this process. We're going to now create an authorization server. That's going to give us a mechanism to bridge the gap between the client and the protected resource in a more automated fashion. It's going to generate these things called tokens. Those are going to get handed to the client application. It's also going to authenticate the users when they show up, so the users can actually log in. We know who they are. We know what rights that they have. It also authenticates clients. So that API key was really nice because it was only given to Carol's application. So we don't want to lose that. We want to know that this is, in fact, Carol's application. And it can manage my authorizations and connecting those three pieces together. So the artifact that comes out of this process is going to be the OAuth token. Specifically here, I'm talking about the access token. This is the representation of those 3 bits. So from the resource owner to the client to the protected resource. That delegation is now represented by this access token. So the client carries it and presents it. The authorization server issues it. And it's the protected resource that actually consumes this token and has to figure it out. So what does an OAuth token look like? Well, turns out pretty much whatever you like. So the first one of these, that's just a random hex blob. That's fine. A lot of nice randomness in there. The second one is a type 4 UUID, so we've got 112 bits of entropy, assuming you don't, that your randomizer hasn't fallen over. The third one, does anybody recognize that? JWT, JOT, yes, exactly. This is a JSON web token. If we have time today, we're going to go into those a little bit more. This is a structured access token, so there is data encoded in there. It's base64 URL encoded JSON. The last one is a selection from a high entropy word list. These are things that are usually user visible, user memorizable. But OAuth tokens, the user should never see them. So why on earth would I use that as an OAuth token? Because I can, right? OAuth doesn't say that I can't do that. And if I have a sufficiently random way to use these things, why not? I mean, there are cryptographic reasons why not. But anyway, now to everyone in the audience, who here has used OAuth 2? A lot of hands going up. All right. So who here has ever logged on using Google? So you use Google to log on to some third-party website. A few more hands. Who's ever logged on to a Facebook application? Who here's ever used Spotify? Who here's used Steam? Gamers in the audience, nice. Who has a smartphone? Not many people here have smartphones or just don't want to admit it. Come on, be honest now. Seriously, if any of those are true, guess what? You've used OAuth. OAuth is absolutely baked into so many web systems and APIs these days. When you provision a new Android smartphone, you are guaranteed to use OAuth because that's how it talks back to Google and connects your Google account. Apple uses it with iOS. The new sign-in with Apple system is all OAuth and sort of OpenID Connect based as well. If you've ever seen this type of screen in a web application, it says, hey, there's a thing that wants to do stuff. Do you approve it? Chances are 95+% you're using the OAuth 2 protocol. It is absolutely everywhere out there. So we are now going to take a little step back into history. Whoops. As I mess up the slides here. You may have noticed that we're talking about OAuth 2. So the obvious question is, what happened to OAuth 1? Don't worry, it went off to live on a farm. It's fine. Back in 2006, the way that people did API access was this password sharing pattern. If you had a website that was advanced enough to have an API, because, well, think about the world of the web in 2006. Anybody hazard a guess what the biggest site on the internet in 2006 was? Was that? No? MySpace. It was, in fact, MySpace, that juggernaut of the internet today, right? The iPhone didn't exist. Well, it was introduced, but the App Store didn't exist. Do you imagine having a full touchscreen smartphone without apps? That just seems weird. All Androids had keyboards. They were basically BlackBerry clones at this point, and still largely a bit of vaporware. The internet was a very, very different place back then. But people were starting to wake up to the idea that you could build a website and have an API and allow people to access your API, not using just the interactive user stuff, but also be able to do API-driven things from third-party sites. Now, the large companies out there, the Google, the Yahoo, and the like, they had their own proprietary versions of delegation protocols to solve this very problem. We had BBAuth and AuthSub, but the problem here was that those were tied very, very deeply to the APIs that they were protecting. So if you were talking to the Flickr API, you were speaking BBAuth. And if you were speaking BBAuth, you were talking to the Flickr API. You really couldn't pull them apart. Similar with AuthSub and the handful of Google APIs that it was protecting. So a bunch of people got together in a back room at OSCON that year and decided that they really wanted to come up with a common protocol that they could use. They didn't want to use these proprietary protocols, but they wanted to extract the best parts of them. Now, these two websites were both looking at using OpenID for login. Now, this is not OpenID Connect. That doesn't exist yet for another 6 years, at least, right? So they're both using classical OpenID for logins, or at least looking into it. And because this is a federated identity protocol, that means that there is no username and password to steal. Well, how can I allow you to access my API if I can't, if I can't let people steal your password to do just that? So again, a bunch of people got together in a back room at OSCON and came up with OAuth 1.0. And it was published without any standards body. It was just kind of dropped onto the web. Here's the thing. And as what usually happens when a bunch of really smart people get together in a back room and invent a new security system, a really bad vulnerability was found not long after, and that was fixed and published in the inscrutably named OAuth 1.0a. So if you were using OAuth 1, that's the version you're likely using. And this version was eventually standardized in the Internet Engineering Task Force, which, as an aside, that's what happens when you let nerds name their own organization, in RFC 5849. Now, this was wildly successful. In fact, it's so successful that the large companies that had their own proprietary systems stopped using their proprietary systems and all started using the standard protocol. Let me tell you something. That doesn't happen. That is incredibly rare, because what motivation do Google and Yahoo have to commoditize this? They saw that this is better for the internet if we are using a common security layer instead of our proprietary systems. And OAuth solved the problem really well. And it also solved things so well that people started using it for all kinds of stuff that it was never meant to solve. Like I mentioned, native apps weren't as much of a thing, but people were like, yeah, we can do that. And Google started adding some weird proprietary extensions to make it work there, because OAuth 1 made a lot of assumptions about it's a web server talking to another web server. People were using it in their data system, in their data centers, being able to talk between APIs directly, basically an API key model. But OAuth is fundamentally a delegation protocol, so that really didn't make sense, and especially with a lot of the assumptions that OAuth 1 was made. And it was all based on shared secrets all the time, so building that into a widely distributed system, nobody was really talking about the cloud yet, but people were starting to build out what we now call it. So that brings us to version 2.0. What we did was we went and looked at how people were actually using OAuth 1, and we modularized it. We took and separated out the different pieces that were previously kind of stuck together, and we added extensibility points where we saw people were already extending it. So different ways to get a token, potentially different ways to use a token. And this was standardized in a pair of RFCs, 6749 and 6750. Already you can see the modularity. This means that instead of a single monolithic protocol, it's now kind of an ecosystem. A colleague of mine likes to call this a protocol generator as opposed to simply a protocol. But the power here is that it gives you a common set of tools and a common set of recipes to mix them together to solve problems. This also turned out to be incredibly useful and incredibly powerful. And it's led to the OAuth that we have today, which is a massively wide and diverse ecosystem of extensions, of related protocols, of applications on top of it, and profiles on top of OAuth that turn features on and off. All right. So we've gotten a lot into what OAuth is and how it got here. And I think it's just as important, if not more so, to cover what OAuth is not. Now, first off, OAuth is an HTTP-based protocol. We did not take the route of things like SOAP and WS Trust that are very hand-wavy. Like, maybe it's over HTTP, maybe you're emailing things. We don't care. With OAuth, we were like, no, this is bound to HTTP. We're going to be using headers. We're going to be using query parameters. We're going to be using redirects. We're going to rely on TLS. And we're going to build that all into the assumptions of the protocol. That said, different pieces and parts of the OAuth protocol have been applied to non-HTTP protocols. So there's a GSS API extension that says how you connect to an email server, for example. So if you connect, I believe, to a Gmail account using a desktop application, you're actually using OAuth there with the GSS API extension so that the IMAP protocol can handle the OAuth token. But somebody had to sit down and define how you use these pieces outside of OAuth. There's also no user-to-user delegation. The delegation in OAuth is about a user to a piece of software. Now, multi-party delegation can be built on top of that. And there's a protocol out there called User Managed Access, or UMA, that does exactly that. OAuth also doesn't say how you do processing of the authorizations that you represent, which is why I do not generally call OAuth an authorization protocol, even though it claims to be that in the spec itself. Because it's not telling you what to do with that token. So we go through this whole thing, and Carol's app shows up with the OAuth token to JIT's API. OAuth doesn't tell JIT what to do at that point. It says, you got the token, you figure it out. There are methods for conveying that information between different parties, and we'll look at some of those towards the end of the class today. As we saw earlier, there's no token format. The token is what's called opaque to the client. This is unlike SAML, and unlike Kerberos, and unlike WS Trust, and a lot of other systems where every component needs to know about the formats and how to generate these and how to parse these. But the token does need to be known how to be issued. The authorization server needs to know how to make these things, and the resource server needs to know what to do with them. But as long as they agree, they can use whatever format they want. The most common format is a JSON web token, because that's a nice cryptographically bound way to carry information inside the token. But it is far from universal, and there are a lot of really good reasons to not use a structured token inside of OAuth. There are no cryptographic methods built into OAuth. There's nothing that says how you have to hash or sign anything. It simply relies on shared secrets over TLS. Now, there are extensions to the OAuth, including Pixie and client assertions and the like, that do have cryptographic methods. Those have all been added in and can be used or ignored depending on your use case. Right? As we talked about, it's not a single protocol. It's more of a protocol framework. The upside of this is that you've got a lot of good pieces that you can use to tie things together for your use case. And you're not paying the cost of having to implement everybody else's use case just to solve your bit. The downside, and this is a big downside, make no mistake, is that two systems can implement OAuth, be completely compliant, and not be able to talk to each other at all. Which seems kind of weird for an interoperable standard, except that it does allow massive amounts of code reuse between systems, especially at the authorization server level, because a lot of commonality and abstraction was put into the thought of how that should work. Apparently, I can't change slides from that side of the stage. And back to what we had at the very beginning. Usually when I teach this class, somebody says OAuth is an authentication protocol. You are in very, very good company and very bright company. The reason that people say this is that one of the biggest applications of OAuth is to implement an authentication protocol. But OAuth itself, as we will see today, has nothing to do with identity. Yes, you're still at Identiverse, but OAuth itself has nothing to do with identity. It has no idea who the resource owner really is. The OAuth protocol does not carry that information, which is what you want for an authentication protocol. You want to know who's there, how they got there. You want to be able to communicate that information. And as we'll see, you can build an authentication protocol on top of OAuth's authorization and delegation system. The parts are all there, and the recipe is pretty straightforward. But OAuth itself is not an authentication protocol. You need to add things to it to make that work. Right? This is not identity. This is still Identiverse. All right. We are now going to dive deep into the authorization code flow. Before I do, though, any questions before we move on to the next bit? Yes, sir.
The authorization protocol doesn't carry any information about the user. What about the claims in it? Doesn't it identify the user?
OK, so the question was the authorization protocol doesn't carry anything about the user, but what about the claims in it? OAuth has no idea what claims are. Go read the OAuth spec. There are no claims. There's no user. That is OpenID Connect. That was added on top of OAuth. No, great question. So the question is, what makes the token considered opaque? And is that related to the use of TLS? TLS is not what makes the token opaque because it is known in plain text to the auth server, the client, and the protected resource, especially if you're using bearer tokens. It's opaque because the client doesn't have to understand or care what's in the token itself in order for the rest of the system to work. So it is most specifically opaque to the client. It's probably not opaque to the auth server or the resource server who actually have to understand it. That said, it can be a completely random blob of information, a handle to some other piece in the back end. Yeah?
Redirection, the user goes to the OpenID Connect, authenticate, gets the token, submits it to authentication server, gets the delegated token, and submits it to the protected resource.
OK, so the question in the audience was about, can I chain these? Hold that thought. Can I chain OpenID Connect and OAuth? One more, then we got to move on. Yes, sir.
I believe I read something that OAuth 1
Uh-huh.
had features like signatures, you had to sign the payload.
Yes.
This was basically for a goal in OAuth 2 in favor of TLS, right? So
Right.
I think that was a good decision.
So, wow, OK. It is way too early for that. So the question is, OAuth 1 had message-level signatures, which is correct, and they were dropped for OAuth 2. A couple of things about that. One, the message-level signatures in OAuth 1, people got them wrong all the time, like constantly. So a lot of times it's very tempting to just make your API work. Just turn off that signature check, because it's unreliable. And the rest of the protocol works fine, and it looks like you're doing OAuth, right? Which is really bad to have security theater of that level. The other thing is that the way that the signature mechanisms were calculated, or the signature bases were calculated in OAuth 1, it was really easy to get wrong. If your parameters got reshuffled, if somebody inserted another parameter, say you had a web framework, which was very, very, very common back then to have frameworks do this, then it threw off the entire signature base. Also, as it turns out, the thought at the time was that if we had message-level signatures, we wouldn't need to use TLS. Well, if I'm an attacker sitting on a plain text HTTP channel, and you're going and grabbing an API, I'm just going to wait for you to go grab your API and grab all your data on its way back because it's coming back in plain text. So you need TLS anyway. And OAuth 2 was largely admitting that, OK, this didn't solve the problem that we thought it solved, and we also didn't get rid of the requirement we thought we were getting rid of. So at the time, yes, I think it was the right move. Since then, a lot of people have been looking to come up with ways to do message level and channel level binding of OAuth access tokens. Hopefully at the end of the class today, we'll have time to look at some of that. There's some interesting work that's been happening there. And a little bit more on that and what might be coming next in the talk that I'm giving this afternoon at 2:40. I think it's in the room right next door on transactional authorization. So that is coming back around. I do still think it was the right decision at the time. All right. OK, so we are going to now go into the authorization code flow. These are the pieces of it. We've met them all. We know what they do. This is how the authorization code flow works. All right, everybody got that? So don't worry, we'll go back. In order to really understand it, you need to understand that there are two forms of communication that are happening here. First off, we've got the back channel. This is your typical HTTP connection. The back channel means that I can make an HTTP request, I get an HTTP response. I can use headers, I can use URLs, I can use query parameters, I can do all that, or I can use message bodies and HTTP verbs. Very, very rich communication, a lot of good stuff. And then we have the front channel. Now the front channel is what allows us to get this user involved, right? This resource owner. Because in the back channel, it's just computers talking to each other. But in the front channel, we are sending a redirect through the user's user agent, their browser. What that means is that a front channel communication is actually multiple HTTP communications. So, sorry, camera guy. So the client is going to tell the resource owner's browser, hey, I need you to go talk to the authorization server. But it does that by saying, I need you to go to this URL. It's a URL that's hosted at the authorization server, and it's going to have some query parameters on it that the authorization server can pluck off the end and say, like, oh, yeah, I know how to deal with that, right? You know, I'm going to have a client ID, I'm going to have a scope, and I'm going to be able to look at all of those bits and get the information that I need. At that point, the user, their browser is talking to the authorization server. So it's kind of a, you know, it's a redirect-based thing, so it's kind of going through this third party where the user is present. The user can then keep interacting with the authorization server until the authorization server decides that it wants to send information back to the client. So it's going to tell the browser, all right, we're done here, go to this URL instead. And that's going to be a URL that's hosted by the client application. So I'm going to send them back to that URL, and I'm going to add my own query parameters to it. Now, the front channel is both one of the best and the worst parts of the OAuth 2 protocol. It's really great because it allows us to separate out all of the bits where we need the user involved from all of the bits where we don't want the user involved. Things with client secrets and access tokens and things like that. One of the downsides, which I will again cover in much greater depth this afternoon in the transactional authorization class, is that OAuth 2 uses the front channel for way too much, as it turns out. We really only discovered that as people have been using it. So now for real, we're going to go through the authorization code flow. All right. Step 0, the user shows up at the client and says, I want you to go do stuff. Step 1, I got to stay over here to click. Step 1 is that the client says, all right, user, I want you to go to the authorization server. Now, I forgot to mention here that the authorization code flow is far and away the most canonical OAuth 2 flow. This should be the default of where you start when looking at all of the different OAuth 2 grant types. Everything else is an optimization of this for specific use cases. So with that in mind, the client application, which remembers, in this case, we're going to say it's a web server, is going to tell the user's browser, go to this URL that's hosted at the authorization server. now that the user's here, the authorization server says, OK, that's great, but who are you? So I need you to log in. I need to figure out who you are. This is the only place in OAuth where identity actually shows up, in OAuth. It's not to talk about OpenID Connect, because we don't have that yet. User shows up, they log in, the authorization server knows who they are. This now gives us the opportunity to get the user's consent. This is huge, because remember that case we talked about before where Carol was Facebook and Jit was Google? I can now go through Facebook and I get brought over to the API that's being protected, and he now has a chance to ask me, it looks like you're coming from Facebook, is this what you meant? Right? Is this really what you want to happen? And by the way, you know, they want to be able to download everything and delete all your photos and do all of that, and I have a chance to say yes or no, and I maybe even have a chance to alter what's allowed there. This is huge because it allows us to scale authorization decisions to the internet as a whole. This is really, really wonderful. The authorization server then kind of takes that state with the user logged in and they've consented and we know the client that's asking from that initial redirect request, and they create what's called an authorization code. This is a temporary credential that then gets handed back to the client. How does it get back there? It's a front channel redirect. So the authorization server tells the browser, I need you to go to this website, and I need you, just basically just go here. Browser's not supposed to do anything other than that. Browser shows up it then makes an HTTP call to the client's web server that has query parameters that include the authorization code. The client can then take that authorization code and turn right back around and send it to the authorization server. Now, it just got it from the authorization server. Why do we turn it around? It seems a little silly. Except that the client didn't get the authorization code from the authorization server. It got it from this HTTP request that came in. Right? It got it from this redirect, from the browser, from an intent launch, something like that. So the client needs to make sure that that actually means anything. So we're going to go back to the back channel. The user's not involved with the process anymore. They've already done their bit. We're going to go back to the back channel, and this also allows the piece of client software to authenticate to the authorization server. So the client can show up at the auth server and say, oh, hi, I am Carol's software. This is the authorization code that somebody gave me. Is this any good? The auth server can take a look at that, and it will basically thaw the state where the user was present, so we know who was there, we know what they allowed, we know who was asking, we can make sure all of that lines up. And if that's all good, remember that state of a user delegating access to a client to access a specific set of resources, that's the goal. So that gets ensconced in this access token, which now gets sent in the back channel, again, directly to the API. And from that point, the API doesn't actually care what happens. Or sorry, the OAuth protocol doesn't care what happens. The API very much cares what happens because it needs to decide what that token means. Core OAuth doesn't actually say anything about that. The authorization code flow, as I said, is the most canonical use of the OAuth protocol, and it is in fact the way that OAuth was originally conceived and designed. All right? Any questions on the auth code flow? We're going to go into some more details in a bit. Yes?
Step 1 or step 2, where the resource owner is authenticating to the authorization server.
Yes, sir.
Does the OAuth standard place any requirements or constraints on how that authentication takes place, what's allowed, can you enforce MFA, things like that?
All right, so the question was, at this step, does the OAuth standard place any restrictions or requirements on how the user authenticates? The answer is no. I mean, technically, you can just have the user type their name and call it a day, or not even that. I mean, it is completely up to you. That said, it is a web-based interaction, which means that you can do MFA, you can do risk-based calculations, you can even, back to the statement that was made earlier, You could even do a fully federated identity login to your authorization server, which, if you're doing OpenID Connect, means you're going to do a whole other layer of OAuth, because that's what powers OpenID Connect, to a different authorization server, which we call an IDP in that case, and then come back to this authorization server, and then continue the OAuth process. And guess what? You can keep doing that. It's turtles all the way down. You can just keep doing that as much as you want, or really as much as your users will put up with the redirects, which is not very much, as it turns out. So, yes, sir.
Are you going to go into where the web client you have drawn up there is also a resource server for a single-page application running in the browser?
Oh, single-page applications. OK, so I need to unpack that statement because there was a lot wrong in there. No, that's why we're all here, man. This is good. So the question was, am I going to go into the case where the client is also a resource server because it's a single-page application? In a single-page application, it's not the resource server because the resource server is still going to be a remote system. It's still going to be an API that you call. The deployment patterns of single-page applications, there are a couple of different ways to do that. We will cover that when we hit the implicit flow a little bit later, and we'll talk about some of the options. And I do want to, if you are working with single-page applications, there is a new best practices standard that's being worked on in the IETF literally right now that goes into a lot of really good detail about how to use SPAs in the OAuth world. So we will get into that a little bit. Yes? How does the protected resource know how to trust the token? We'll get there. The answer as per OAuth 2 is, it doesn't know and it doesn't care and it doesn't specify. A short preview is that your three main options are, look it up in some sort of local data store, look inside the token itself, or call a service to get information about it. We'll get into those options a little bit later, though. Yes, sir? Great, so we'll get there. So we'll if you're going to ask about the implicit flow, we'll get there, and we need to move on.
The reason I mentioned because in this case, access token is never exposed to the user, but in implicit flow it does. So how can we make it any better?
We will discuss the implicit flow when we discuss the implicit flow. Thank you. All right, there's a lot of people in the back of the room. Feel free to filter in, or if you're just planning on leaving shortly, feel free to hang out there. That's cool, too. All right, last one until we move on.
Practices for SPAs, is that part of an RFC? Or?
OK, so the best practices for SPAs is going to be an RFC. It is in the process of that right now. It's relatively early in the process. So there's a lot of writing that's happening. So you can find it. It's at the stage of what's called an internet draft. And that's sort of a pre-RFC state. So it's being worked on in the IETF now, though. But if you look for best current practices for browser-based applications in OAuth, it'll probably show up. Aaron Parecki is one of the main authors of it. OK. So now we're going to talk about refresh tokens.
Justin, you're not taking a break?
Not yet. We're going to take a break in just probably just a few minutes. We're going to go through refresh tokens and scopes, which will only take a couple of minutes. And then we'll take a break, because I totally understand this is a long class. All right, so access tokens work after the user disappears. So think back to that authorization code flow. The user goes through all of those different bits, and then as soon as they come back with the authorization code, they can just go away, and the entire rest of the process, including using the access token, that just happens without them. And what happens when the access token stops working? Maybe it expired. Maybe somebody went and revoked it. And the client is going to go and it still needs to access this API. Well, the failure mode in OAuth is to do OAuth again. Right? You know how to get a token in the first place. Why not just do that? And this is part of OAuth 2's design principle of making things as simple as possible for the client application. There's a good reason for that, too, is that think about the developers that are going to be focusing on each of these different apps in the ecosystem. Authorization server. It's a big security component. You're probably going to have your best security engineers building and deploying that thing. These are specialists and experts. They're going to generally know what they're doing. If they don't, hire somebody who does, or buy a server from somebody. There's a lot of people here who will sell you this. API developers. They care a little bit about security because they don't want their API to be the thing that breaks everything. So they will do the bits that they need to make it work. And if you say, here's how you go and look up the token, as per the question earlier, then yeah, they're likely to do that and do their best to get that right. Client developers. The job of a client developer is to make an application that uses that API. Security is what's getting in the way of allowing them to do their job, of letting them build that application that uses that API. So client developers are not motivated to do security properly. They're motivated to do it quickly and get it out of the way as much as possible. This is one of the biggest problems with classical security systems like SAML, WS Trust, and even Kerberos, that clients are pretty complex in all of those kinds of environments. Even in OAuth 1, with all of the signature mechanisms that we were talking about before. In OAuth 2, we realized that there are going to be client developers out there, and most of them out there are not going to want to care about security. Like, it needs to be as simple a recipe as possible. So you take the most dead simple client, its access token stops working, it's going to throw an error, throw out the token, and then get back to the state as if it had no token, which it already knows how to deal with. So I'm going to go bug the user, they're going to get me a new token, that's great. Problem with this, what if the user's really not there anymore, and I still need to access things, right? Do I really want to send the user over every single time? In a lot of cases, no. So we have this thing in OAuth 2 called a refresh token. Now, a refresh token gets issued right alongside the access token, and it's only good for getting new access tokens. That's the only thing you can use it for. You cannot use this at protected resources. You cannot send this out to all of the different APIs. And it's only presentable at the authorization server along with the client's credentials, which means that it is a little bit better than the OAuth bearer token because it needs to be presented along with whatever credentials the client has, if it has them, in order to actually work and get new access tokens. So refresh tokens are a pretty simple concept, but very powerful when used correctly, because the refresh token starts to represent the lifetime of the user's grant of access to this application. Because that means that those access tokens, which are bearer tokens usually, and which are being sent to all sorts of different applications, they don't have to live very long. So say your API is set up such that the user shows up, they interact, you're going to make a whole bunch of calls in about 5 seconds, and then you're probably not going to use it again. Your access token doesn't need to live for an hour, people. Right? That might be the default, but really, when you're building this stuff out as the authorization server, think how long your access tokens really need to live. Because it is a very easy thing for a client to be able to take a refresh token and go check that. Because think about the code path of a client that deals with refresh tokens. I have an access token. Yes. Did it work? No. OK. Do I have a refresh token? Yes. OK, I'm going to try that. Did I get an access token? Yes, I'll use it. If no, OK, well, I guess the refresh token didn't work and the access token didn't work. And now I just go do OAuth again. My end failure state is still the same. It's still very, very simple to program this. And that's incredibly important when you're building out a security system. All right, we are very quickly now going to talk about scopes, and then we'll take that first break. APIs get designed in a lot of different ways. And the naive way is to say that if somebody has authenticated, if you get an access token, then you get the whole API. And that's great. But that was the case when we went back to the very beginning, when Carol was stealing my passwords from me. And we all agreed that that wasn't a good thing, because I want to be able to build my API in such a way that I can differentiate access. Maybe it's read-only. Maybe, so let's talk financial APIs. Maybe I am totally okay with you getting my account history, like your Mint, right? You can totally get my account history. You can look at all of my transactions. That's all great. I don't want you to be able to transfer money, though. But if you have my username and password, you can do everything that I can do. With OAuth and a well-designed API, we have a way to do that. We can split the API based on the kind of access, maybe the kind of resource. So I'm getting pictures because I need them printed, but you don't need my geolocation for that. You don't need the time and date stamps and all of that to print out a photo, right? Maybe you can get my profile information, but you can't get my medical records. Or maybe you can get my medical records, but not my profile information. So say you're a researcher, and you're trying to get population information for tracking diseases and the like. So it's not always like you start with identity and then build out data from there. That's how we get privacy leaks. It's much better to think of these things as different components, different attributes, different aspects that can then get built together into these APIs. Scopes allow us to do that in a really simple way. They are a simple string that represents what the token can do. Now, in OAuth 1, we didn't have any scopes at all. It was you get the token, you get the API, that was the end of things. Scopes were a way in OAuth 2 to be able to say, the API can decide, you can read, write, do this, do that. And the client can ask for specific scopes, and resource owner gets to approve them. And then ultimately, and here's the important part, that access token gets bound to the set of scopes that were approved, which means that when it shows up at the API can then look at that token and say, like, oh, this is a read-only token. You know, it can get that information and then make the decision of, you're not making a read-only call here, so I'm not going to allow this. Or maybe your token says, I only give you the public profile information and not your email address, right? There's a lot of different ways to split that up. We are going to take a 5-minute break here. Let people stretch, use the restroom, grab some water or something like that. When we come back, we're going to look at the different grant types and flows of OAuth 2. We also have bits on how you do identity on top of OAuth, how you do structured tokens, and hopefully by the end of the day, we'll be able to hit bound access tokens as well. All right? Thank you all.